Hello, my name is Junho Kim from Seoul National University. In this presentation, I will present our paper titled PICCOLO, Point Cloud-Centric Omnidirectional Localization. Visual localization is a cheap localization method that finds the camera pose only using image input. While perspective cameras have been widely employed, their limited field of view is vulnerable to scenes with repetitions or changes. Omnidirectional cameras, equipped with a 360-degree field of view, are beneficial for such scenarios as they can handle the global context of a scene. However, severe distortion in omnidirectional cameras make it difficult to directly apply existing visual localization algorithms. We present PICCOLO, a simple, efficient algorithm for omnidirectional localization. Given a 2D omnidirectional image and 3D point cloud of a scene, we aim to predict the camera pose. Our method works in an off-the-shelf manner and does not require any training of neural networks or ground truth poses of images. PICCOLO minimizes a novel point cloud-centric loss function called sampling loss, which takes the entire point cloud into account. Sampling loss measures the difference between the point cloud color and its projected location's sampled color. To illustrate, suppose we have 3 points xj, xk, xl in 3D space, along with their 2D projections under the candidate camera pose shown in red. Sampling loss is defined as the color difference between the 2D-3D modalities. Note that our formulation is fully differentiable and thus suitable for gradient descent optimization. Also, by avoiding the rendering procedure often used in photometric loss, sampling loss overcomes visual distortion and is cheap to compute. Note that we do not extract any features or train a neural network with labeled pose from a dataset of images. The only thing we need is the color of points in images and point clouds, which is usually provided from raw measurements. Unfortunately, sampling loss may contain spurious local minima. Given a point cloud and query omnidirectional image, what we visualize on the right are the sampling loss values computed over different locations in the point cloud. One can clearly see that many local optima are present. To escape local optima, PICCOLO first selects decent starting points from various candidate locations within a scene. For each selected starting point shown in green, gradient descent is applied to minimize sampling loss. Here we show the optimization trajectories of selected starting points from the previous step. At termination, the candidate pose with the smallest sampling loss is chosen. In this case, the starting point marked with the box has converged to the global optimum after gradient descent. Here is how gradient descent steps update the projected point cloud, which eventually converges to match the query image. We illustrate the trajectory of one starting point, but usually multiple starting points are optimized. Now we briefly share the experimental results. PICCOLO is extensively evaluated in a wide variety of scenarios where omnidirectional cameras are present. We first show results from indoor and outdoor localization. Note the repetitive chairs or trees in the scene, which are known to deteriorate the performance of visual localization with perspective cameras. PICCOLO can successfully localize from both images. In practical application scenarios, omnidirectional cameras can be handheld or mounted on robots. These cases are challenging, since large portions of the image could be occluded by hand or robot, as marked in boxes of red and yellow. We demonstrate that PICCOLO can effectively localize pose in both scenarios. Finally, PICCOLO shows competent performance in scene twist changes, although there is no additional functionality in PICCOLO to deal with such scenarios. The global context provides enough amount of evidence from color samples for omnidirectional localization to succeed. In conclusion, we propose PICCOLO, a simple, efficient algorithm for omnidirectional localization. PICCOLO minimizes sampling loss, which enforces each point to correctly sample from the query image. Our formulation is point cloud-centric, which makes our algorithm immune to visual distortion in omnidirectional cameras. Experiments show that PICCOLO can successfully perform localization under a wide variety of practical scenarios. We expect PICCOLO to be extensively applied in virtual reality, robotics applications where omnidirectional cameras are present. Thanks for listening.